And so I alluded to a little bit earlier how we commit and expend on a project is oftentimes different to how we want to track all of our work packages and progress, physical progress on a project. And so what Cloud EPC's progress tracking does is there's two main things. One is there is a permission around cost. And so you have the ability to load simply all the hours into the system and hide cost in the view through a very simple permission. In the demo account, I do expose cost, but the reason for that is oftentimes the cost engineer or the quantity surveyor rather may not need all the cost information, or you want to allow your vendor into the system and you simply want them to update their progress, but you don't want to expose all of your project cost. And by isolating into modules and being able through permissioning to turn off the cost data, it gives us a pretty powerful module for simply tracking physical progress and then aggregating that progress at a later date and multiplying that to our budget to calculate our earned value. The other thing it allows us to do is also isolate sensitive information, such as, all-in labor cost or that type of sensitive data to folks where permission-wise we don't need to expose that. You can simply turn off the cost module and only give relevant progress tracking information to that individual, whether it be an employee or a vendor. So from there, you simply load your deliverables into Cloud EPC at the appropriate level of detail. And I make that distinction because when we built the system, that was something very important for us as Nexus PMG to be able to develop for and manage within our system, Cloud EPC. And so if I go back to the example of if we're working with an investor, we may have for every single budget line item I showed you a single progress item or work package and lean on the owner's team, the contractor to feed us detailed level information that we can use as a checkpoint to update our progress. But if we are a contractor or an engineering organization, we want to probably have a different level of detail for our work packaging to be able to earn out our project. And so in this case, we're loading this as, let's just say, a demo power plant, and we're going to load engineering, procurement, and construction work packages into a single database. And so if we were to start with P&IDs or process engineering, we could load this line item as we did here as a single line item for one P&ID, or we could expand this and load n number of P&IDs, let's say by sheet. And so if we're estimating by sheet, we can load the entire estimate by every drawing we thought we would have to do, or we could have it at a slightly higher level and then maybe morph that into more detail as it becomes available. And so that's one of the big differences between the cost module, which works really at how do you commit and expend a job, to the progress and performance module, which is really how are we going to manage physical progress on the project to be able to know when we say we're 33.8% complete, how are we actually tracking that and earning it out? And so what progress items consist of are two different elements. It's a master record and then detailed records, which show up down here that are referred to as our rules of credit. And so every element on the top or a work package, in this case, we're looking at engineering, but we can also load pumps as construction installation. We have the ability to control what is our rules of credit on how are we going to earn out, or what are the steps required to completing this deliverable. And so looking at this pump line item, we have to be able to receive it, set and install it, preliminary alignment, final alignment, and then punch and accept it. Whereas maybe engineering, for design criteria, we have to define and agree on the scope. We have to validate the distribution models, execute simulations, and then actually prepare the final review and report. The point I'm trying to make here is we can create different steps for these different data elements because how we complete each one of these work packages is going to vary depending on the type of work package. And those rules of credit are stored as templates in our system. And so you can create unlimited number of templates and then apply those templates to your deliverables. Just like other parts of the system, we have a very nice Excel import. You can assign those templates as a single line item on every deliverable for your project, import it in the system, and you're off to the races and you're running. The other thing that happens is you provide a estimate of effort that's required, or your budgeted cost and budgeted hours of the work that's scheduled. And so in this example, for engineering data sheets 1, we are allocating from our budget table. So again, the idea of a bank account I said earlier is, let's say we had 980 hours for data sheets. We can, or maybe it's a little bit higher, we have 2 sets of data sheets, call it 1,000 hours for data sheets. 900 of those hours are allocated to data sheet line item 1, and then the remainder 100 hours are allocated to data sheet -2. We also have the ability to allocate the cost, just like the hours, and through permissioning, we can hide the cost from the end user. And that becomes our budget value on every one of these line items. From there, yes.
One thing that I want to point out also is the rules of credit. The reason that we allow multiple steps in those milestones are that we can weight out each of those individual rules of credit so that you earn different hours depending on which step of the rule of credit you take, right? So that's a good thing to show.
That's a very good point. And so, when we think about steps in Primavera, for example, which is slower to follow in this methodology, weighting everything equally is just not practical, right? And so if we think about foundations, the amount of effort to form that foundation versus strip it is very different. The amount of work it takes, or the effort from a weighting perspective on this 2,000 work hours, the data model, or the weighting rule of credit model, is stating that to place it, it's 10% of the effort. To install the rebar is 30% of the effort, and it's 45% of the effort to actually physically form that foundation, et cetera, et cetera. And so when we think about actually updating progress, which I'll talk about in a second, we effectively apply a sum product calculation. And so we take into account the weight value, like a GPA. So, one class with 4 credits doesn't count the same as your overall GPA as a class with 1 credit. And that weighting of a 4 credit weighs heavier on your GPA than a 1 credit is the same methodology, where we take the percent complete times the weighted value across all of the rules of credit to come up with our overall complete right here on the work package or the progress item. And so we do time phase in the system, although we've created a UI that makes it look like it's a very flat. And so we pick what week we're updating for. We update, let's just say we were complete. And then we simply took 100% times that 10%, and that 60 something odd percentage I was just referring to is now 72.6% complete, effectively using that weighted value. And then the earned value, or in this case, that allocated 2,000 times the 72%, is going to give us our earned value of 1,400 hours in this case. Performing that same kind of mathematical function across all of your work packages or progress items then gets aggregated back up to the budget view. And so we have our big 5, we have a control budget. In this view, we're looking at it through hours and not cost. I can go do the same thing in the cost module and look at it through the lens of not effort, but cost. But it's the same math. But we can also look at the payroll, or the labor hours that have actually been charged, our labor hours associated with each big 5 from a budget perspective. What we physically earned, our earned divided by our budget, it becomes our percent complete. Our earned over our actual labor effort spent to date becomes our PF. And just like in cost, we have our current budget and our current forecast. And so if we were to look at it from a client perspective, we, and if the contract required, I'll clarify that, to state your performance factor, you would be able to run a current budget performance factor, and let's just say, had you estimated the extra 10 linear foot of pipe in that example I given earlier, where you originally had 100 and now you have 110, we could add those additional hours into the current forecast and run a current forecast PF. You can also opt to just not use the trend and the current forecast and just run the approved budgets and run everything against your current budget. It's how you choose to apply the system. But that idea of a detailed level advanced work packaging tracker and then rolling that back up to our budget tables, also being able to layer in our timesheets into the system, we can now look at our actual labor spent, our earned value, and our performance in one module. One of the other things that's really different, we believe, in our system is how we think about quantity surveyors and the job of a quantity surveyor and tracking quantities. And so if we were to use this layout function, is we can load all of our work packages into the system, and then we can create very specific layouts. And in this case, I have a demo layout. And what this demo layout is set up to show is how we treat quantities in the system. We could have stopped at this point and, effectively have a full earned value management system. We have our budgeted values. We can, I hadn't showed it yet, but we can spread those out over time. We can do CPI and SPI. We can earn our value. We can look at what we've actually spent. But oftentimes, especially as a construction contractor, we need to be able to substantiate our 50% complete at a rule of credit level. And so 5 out of 10 widgets installed, in this case, 250 out of 500 tons of wire and rebar, in Cloud EPC is the equivalent to 50% complete. And so there's also a mobile application and you can use in the field. But in the field, if you're a constructor and you really want to track physical progress, you can take off every element that you feel appropriate to be able to load not just quantities, but to validate and substantiate physical progress. And let's just say we installed those 500 tons. You have to pick a week, and so we're doing it for a week of June 12th. We can now flip back over and see that 50% complete is now 100% complete. And so the idea of, if you have that data available, you're taking that data off, and oftentimes we see, especially industrial contractors, definitely E&I contractors and piping contractors, they have these very large spreadsheets. Every tab in that spreadsheet is a different discipline, slightly different data points with a different rules of credit that will have that quantity value, some sort of unit rate methodology that would give you, for that quantity, total number of hours and cost, and then they have their rules of credit as columns going across that spreadsheet. Our system effectively provides you that in a database and then gives you the ability to go through and then track all of that data, where we really, and not just the earned value, but also that quantity-based metric, where we really are proud of our system is that next level of coding and what you can accomplish when you move from a spreadsheet into a database. And so just envision, we are a piping contractor and we have every one of our isometrics loaded into the system. We've been able to take off everything off that ISO. We know now how many linear foot of large bore greater than 2.5-inch carbon steel pipe we have. Our WBS is telling us how much of that's in the boiler, how much of that's in the turbine, how much of that is in balance of plant in this case. We've also gone through, and based on those isometrics, we know now which system and subsystem that pipe is in. We've also assigned that into a test package. So a group of ISOs will then get grouped into a test package because we're going to have to hydro test that pipe. We also know which area and sub area, if we're not using it here, that pipe is in. And then, oh, by the way, any other 12 other data elements, whether it's dates or just generic text, we can code into the database. At the rule of credit level, what we can then do is take all of that coding and use this really robust pivoting structure in our layouts and start answering some really complicated prod questions on projects, such as, if we were to think about it, WBS in our case is area, perhaps we want to look at pipe and total hours and quantity. So total quantity, how much do we have planned? what have we actually installed, what have we earned, total number of hours, what have we earned against those hours. And we want to look at that by area, but then we want to start answering some really hard questions underneath that, such as we want to now say, let's look at this by system, or rather test package. And I don't know if any are coded, but we can now drill down by turbine area, and none are coded. Had we coded some, we could see that turbine area has 5 test packages in it. We can look at now those, how much of that pipe is actually physically engineered because we have our phase coding. We also can look at how much of it is installed and how much of it is commissioned. And so it gives us this ability to slice a very complicated project based on the coding that we've implemented and answer really hard questions. I mean, depending on how you take off and what information is available in your ISO, you know, boiler elevation 350, you know, X amount of pipe, X amount of tray, X amount of electrical, you can really get some comprehensive data that you can pivot and slice in this view and then save that off as a layout to be able to answer some complicated questions and also coordinate between the phases. What portion of engineering boiler area elevation 300 are we engineered versus procured versus installed, depending on the level of data that was available and the coding structures that were implemented. And that's something that we're very proud of from being able to get down to an atomic level, and what, quite frankly, quantity surveyors have to live with every day in the field, but then also have to report back up to the scheduler. And so again, that's just one of the things I kind of glossed over with all the functionality, but we also have the ability to import our Primavera schedule into the system. And so just like we've been able to cost code an area, a test package, we can, and I use the term cost code loosely, but code rather, we can code our schedule IDs on every one of the steps. And so if we were to think about this as a level 4, level 5 level of detail that's getting loaded from a work package perspective, in Primavera, we have our level 3. And so maybe that's foundation, area 1 foundations, and in Cloud EPC, the progress items would be each foundation in area 1, and then the rules of credit would be each of those steps, like form, rebar, embeds, placement. And all of those can get coded up to a particular schedule ID, and this is where it gets really powerful from tying everything out, is just like I showed you for test package, we can come over here, we can enter this pivot mode, we can save a layout, but now we have our schedule ID. And we can pivot this data set and look at it by schedule ID. We can look at what's our percent complete, how many hours, how many linear foot of pipe, how much quantity of electrical, linear foot of tray, linear foot of cable do we have on each one of those schedule IDs. And we can keep those systems in check between 2 databases. There's a really nice little export that you can do right to Excel and import it into Primavera. And if you're using web services, we do have a beta at this point where we can integrate with Primavera through web services. And so the grand scheme of things, all of this gets rolled back up into our budgeting module, and all of that data becomes available in our reporting module.